you, Professor Zhang, for your introduction. And it's my great pleasure to give this first talk for the journal. And as Professor Zhang also introduced, my topic is about towards human-centered building design and the environment sound perspective, because my field is acoustics. So I like to explore how we can consider human-centered design in uh, building and the environment from sound aspects. Just see how can I move. Why I can't? Oops. Okay. So firstly, why we talk about the sound? Why it's important? Uh, I know there are some acoustic experts here, but also some people are not familiar with sound. So in Europe, there are 80 million people suffer from unacceptable environmental noise pollution, according to WHO data. And the social cost of transport noise itself is about zero point 0.2 to 2% of GDP, which is very, although percentage is small, but a very large number if you transfer this into euro. And the noise effect, as we know, include hearing impairment and also speech interference. For example, in school, you can't hear a teacher clearly if there's noise, and also, of course, sleep disturbance, and also some health. If there's high noise level, there are some health impact, and also performance reduction. A study shows in London, noisy schools children performs worse than those children in quiet schools. And not only performance, but also economical impact. Uh, so in Europe, study shows if you have 1 decibel increase of noise level, then the house price will drop by 0.6%. And there's also social effect. Our study shows if you have natural sound in urban squares, people turn to have more social interactions. They turn to talk to other people more willingly. And also, if there's noise, people turn not to help others. That's also proved by some experiments. So you can see sound is very important aspect in our building and environmental design from all aspects, from social, economical, and health aspects. And also it's very uh, kind of a clear problem. So today I'll explore how we can consider acoustics from perception viewpoint, because a lot of work has been done on the engineering science aspect about sound propagation, decibel levels, but at the end of the day, we are targeting on achieve good acoustic environment for people, for the users. So we need to think about uh, human-centered aspect of design. So that's my focus today. It's about acoustic perception of various outdoor and indoor spaces. So I'll go through different kind of spaces and just show you how people perceive the sound environment in those spaces, and how we could and should consider sound design in those places. from human aspect. And from here you can see I didn't include places like a concert hall or conference center because those spaces are, we call it acoustic spaces or functional spaces. There, the acoustic function is most important parameter. If you go to a concert, you want to hear music nicely. Uh, so that's main function of it. We call it acoustic building. But actually, we don't go to acoustic buildings every day. I don't know how often you go to concert hall. Uh, so everyday space, like public space, hospital, shopping mall, library, and swimming spaces, that's place we go more often. So today I'll concentrate on, we call it non-acoustical spaces and see how in everyday spaces we could consider acoustics from human-centered aspects. So let's start from outdoor spaces, urban open public spaces. This is survey we did some time ago, and basically in this city center square in the UK, we ask many people, thousands of people, uh, two questions. One is, how loud do you think this place is? And in the same time, we measured after or before we ask someone, uh, we measure sound level with sound level meter and see what's the correlation between the decibel level and also people's perception. So you can see with increase of sound level, people do feel is louder, which is very understandable, which also shows this study is valid. But we also ask another question: what do you think the acoustic quality is there, acoustic comfort? You can see the correlation become much less. Uh, Also below about 65 to 70 dB. Actually, there's no influence from decibel level to people's acoustic quality evaluation, which means what affecting people's evaluation of quality depending on non-acoustical factors. For example, who you are with, where are you, and when is it, or this kind of non-acoustical factors. This is actually the point I like to make. We need to consider uh, human-centered design rather than assuming that if we design decibel level to certain value, you should feel good. But actually, that shows not. So that's the key point I like to make. Why we need to consider human-centered design. Of course, you can see here if the sound level is higher than 65 to 70 dB, then with increase of sound level, whatever sound is, whether it's fountain or traffic, people's evaluation about acoustic quality become less. So we do need to consider physical aspect as well in with human perception. So they should be integrated. So another example during the COVID is people normally assume the quieter the better. So COVID give us golden opportunity to see whether the urban environment quality will become better if it's become quieter, because during COVID, there's much less traffic and the noise level in London decreased by 8 dB average. So people would think, okay, this is a golden opportunity to experience very nice, quiet environment. But unfortunately, during COVID, the noise complaints increased by 3 times in London, although the noise level was 8 dB lower. That's again because if the environment is quieter, then you hear more unwanted sound. For example, your neighbors' uh, lawnmower sound will become clearer if there's no background noise to mask. So this again shows we need to consider human-centered design rather than just a simply physical aspect like decibel level. So over the last 20 years, this concept of considering human human-centered design has grown and attract a lot of interest. That's mainly because there's an EU directive on environmental noise uh, control and management. And the one action is identify quiet areas to protect. But now we realize quiet doesn't mean lower decibel level. We need to consider all aspects. Therefore, over the years, uh, we, together with many colleagues, define the soundscape as acoustic environment as perceived or experienced or and understood by a person or people in context in certain environment. This was the ISO definition on soundscape. So this move step forward from traditional acoustic environment, which just consider more decibel level, to human-centered design, which is pushed by EU directive on protecting quiet areas. And this suddenly moved the traditional sound engineering discipline to multidisciplinary, including all these media arts, music, ecology, human geography, and political science, religious study, or different disciplines. We need to approach this from science, engineering, social science, humanity, and arts this field rather than just from science engineering side. So with this concept, we can regard sound as resources. We can use good sound and not just regard sound as a waste. And we can also use this approach to promote health. If we design good sound environment, we can make people's health better rather than just say we want to reduce noise in order to not make people's health worse. So we can make a plus rather than preventing to be negative. So all this actually is pushed by the EU directive and also kind of made big progress by researchers and practitioners. So there's a big tendency from noise control to soundscape creation. So to go with this tendency, we have done a lot of work on how people evaluate soundscape or sound environment. We found in terms of sound level evaluation, occupation, education have more influence than other factors such as age, gender, or whether you're local or not local. And for some behavioral factors, including whether you have earphone, whether you're reading or moving, the effect is also it's not very significant. But watching behavior, whether you're looking, is quite important, which means audio-video interaction is quite significant. In terms of acoustic comfort, because these are two questions, one is how loud, another one is how comfortable you are. Effect of view assessment, watching behavior, even more significant, shows the audio-video interaction. And essentially, our human being shows a positive attitude towards natural and cultural related sound, which is expected. And also long-term environmental experience are important, whether you come from or live in a quiet area, affect your evaluation on certain places like open public spaces. And also people's age, gender, or this demographical factor affect people evaluation as well. For example, we found with increase of age, people turn to like bird sound more. This is percentage of favorable for certain sound or annoying or medium. You can see when people become older, people turn to like bird sound more. And that's another opposite sound calm music. And with increase of age, people hate this kind of artificial sound more. So we need to consider all this kind of different human perceptions and design accordingly, rather than just say, if I design decibel level right, you should feel good. And not only demographical factors, but also cultural differences. This is across the European large-scale survey we did with European partners. And this is Greek cities, that's Italian city, and the UK and Germany. We again ask people, what do you think about water sound? Favorable, neutral, annoying? And what do you think about other different kind of sound? And you can see for water sound, UK and German people like it a lot. You can see 80% around 80% of people feel it's favorable, but in Italy it's only less than 30%. Um, so this, even within Europe, there are a lot of differences in terms of sound preferences. And another example is, do you like surrounding speeches? You can see in the UK and Germany, people don't like surrounding speeches in open public spaces. Most people think that's neutral. But in Italy, almost 50% of people like it. So you can again see this kind of cultural differences. And even more, we ask people, do you like bird sound from outside? And 70% of people in Sheffield like it, but this percentage is only 32% in Taipei and 25% in Beijing. And do you like music from outside? Only 4% of people in Sheffield like it, UK. And in Taipei and Beijing, the percentage is much higher, 26 and 43%. So I hope that's enough for open public spaces. And let's now move to another type, inside building type, hospitals. Uh, so we surveyed about people's sound preferences, because if you want to consider decibel level, doesn't matter what kind of sound, but do different sound make people uh, feel differently? This is results. You can see uh, how about speech in hospital, other people's speech? You can see um, many people very much don't like it, and not almost nobody like it. And the calling sound for people, that's fine because that's got some signals. And walking sound is neutral. Some people don't like it. And general kind of crowded sound, people don't like it, but not that much hated like speeches. And uh, mobile phone ringing, it's kind of neutral. Some people think that's fine, but some people don't like it, but not very much dislike. And another interesting thing is between doctors, nurses, and patient, the perception is very different. You can see doctors really don't like surrounding speeches very much, but patients are okay. So we should also consider the difference between doctors who or nurses who are working there every day and patients who only go there occasionally. And this is about their noticeability. So whether they can hear it or not, whether they notice it or not, there's not much difference between doctors and the patient. But about the preference is very different. So they can hear it, but they perceive it differently. That's another indication we should consider human-centered design. So how about effect of sound on people's physiological aspect, because previously you like it or not like it, but if you don't like it, maybe it doesn't affect your health. That's fine, but we should also consider whether it is true to about physiological aspect. So this is a laboratory experiment we did for people to listen to four kind of sound: ambient sound, mechanical, artificial means kind of human sound, and the music. Uh, you can see when people listen to this four sound, heart rate, there's no significant difference. But in terms of skin conductivity and recovery rate, there are differences between different sounds. The star means significant difference. Music will give you higher recovery rate. And if you think about self-reported anxiety score, which is kind of health aspect, also is self-reported, the significance difference exists between all kinds of sound. There's still four kinds of sound, but you can see there are a lot of significant difference between different sound. So for uh, perceived restorative score as well. So this means when we have different kind of sound, not only perception-wise, but also in terms of health aspect, there are differences. So in hospitals, we do need to consider sound type very carefully. So only know the difference, know how bad it is not enough, because we are designers and engineers. We need to think about how we can improve it. So we did silence ward intervention. So in the hospital, we installed some uh, sound treatment, like seal the door better, and also have acoustic ceilings to reduce the noise disturbance and also reduce reverberation time. So this is normal ward, silent ward, the difference between them. And that's different acoustic parameter, LEQ, which is average over the time. L10 is the higher percentage, the peak ones, and L90 is kind of background. L10 means 10% of the time the noise level is higher than certain value. L90 is 90% of the time the sound level is higher than certain value. That means this is peak, this is background. You can see with this treatment, you create some differences. So this is difference between normal ward and silent ward. You can see the noise level is quite different. Also, it's different in different time. The reason is if you don't have acoustic ceiling, people reverberation time is long, so they turn to shout more. But if acoustic is good, then they turn to speak quietly, relatively. So actually, the change is not only physical, but also behavioral. If you have something, I think everyone knows the famous phenomenon. If a place is clean, tidy, people turn not to throw rubbish. But if a place is already very messy, people just say, okay, there's a lot of rubbish, why don't I just put another one? So if you have some acoustic treatment, make it quieter, nicer, then people turn to behave better and uh, walk quietly, speak quietly. So this is additional bonus. That's why in different time, the difference is not the same. And with this intervention, let's see what is the effect on perception. So that's a comparison of the noise impact in various aspects in normal ward and silent ward. This is normal ward, that's silent ward. You can see people's conversation quality, sleep quality, emotion, and recovery rate are all improved. So with this quite light-touched acoustic treatment, which not only change the sound level, reverberation, but also change or affect people's behavior. This in turn make a lot of improvements in all aspects in terms of sleep and also health aspects. And given the importance of human intervention, so we also developed a system which you have a bracelet and give people indication how loud this place is, and then have a mobile terminal and have a monitor. So basically, this is kind of noise monitoring and reminding warning system. So if it's too noisy, there'll be some kind of signal. So you wouldn't change the hospital ceiling, doors, but just kind of try to manage people's behavior. And uh, this is actually quite effective with this system from monitor to mobile terminal to smart bracelet. Actually, it's made a lot of differences in terms of sleep quality and other kind of sound level as well. So this shows how important it is to manage noise, manage people's behavior for improving sound environment. So if you want to know more details about all this, I put the reference, the book, the papers, you can find more details. So now let's move to care facilities. Uh, that's another place. Sound is quite important. Not like This is not like a concert hall. You just design sound more objectively, but this is very much affected by people's perception. So this is the sound level of a care home in different time. You can see how variable the sound environment could be, which means how potentially we can design something or demanding of design something because it's so varied and there are a lot of possibility and potential to improve it. So again, we did a large-scale survey and see what is the relation between the sound level and people's perception. Because we are talking about human-centered, so perception is very important. This is about loudness. This is not actual loudness, it's about perceived loudness and intelligibility, how clearly you can hear people's speech and how noisy it is, and preference. What's your preference? You can see the relation between sound level and those four aspects of subjective evaluation are quite different for activity sound, speech sound, background music, and mechanical sound, which means we should design those sound and the foreground music and need to be sound specific, not just assuming sound level will affect people's perception equally for all kind of sound. So given that, we should also consider how different kind of sound, those are all people regarding as positive sound, can improve people's perception. So we did again large scale survey in two Chinese cities, a range of care home and also care activity center for older people. So you can see about pleasant, arousal and annoyance, quietness, activities, effect, and overall evaluation. Those different sounds have quite a different effect. So it's not only, okay, I'll give you some good sound, you will feel better. So different sound have quite different effect. Although they are all regarded as a positive sound, they are all positive, but at different degrees. So this shows again how important it is to design different kind of sound. And this is a comparison between different age group from 60 to 69, 70 to 79, 80 to 89, and over 80, 90. So you can see uh, for same sound, even they're all regarded elderly or older people, but the effect on different age group is quite different. So we need to consider different age group in care homes differently according to what kind of care homes. And in terms of gender, it seems the difference is much less compared to age. So that's another kind of evidence when we think about design. This is another set of study about, again, based on perception, about uh, music's effect. So with music, without music, the evaluation score is very different. And uh, this is this overall effect. This is effect on different aspects, pleasant, arousal, and dominance. These are three dimensions of emotion. So you can see, firstly, with music, without music, there's big difference. And secondly, the difference is different in different dimensions of the uh, emotion. And this is different music, slow music, fast music. Again, there's difference. And also different dimensions are different. And this is a comparison between uh, natural sound and the music. You can see they're also quite different. I wouldn't go to detail about how to design, but just want to show you um, the importance or need to design this. Another aspect is about for different activities, because that's important for care homes. Uh, Many people can't go outside, go to city or rural areas to enjoy. They just stay care homes for a long time, so they have different activities. So for different activities, what kind of sound do you want, and what kind of sound do you not want? So we have a water sound, bird sound, uh, rustling trees, ocean wave, and music, and um, uh, other kind of music. For example, for uh, table tennis, seems people want kind of music. Uh, Birds are okay, but not that preferred for music. And for example, sitting still, so people want bird sound more. So because the activity hall have different activities or different zones, so if we design different zones differently according to their preference, that'd be great. And this is not what they don't want. Again, table tennis, many people don't want bird sound. You will see, why this is wanted sound, this is unwanted. Of course, this shows people are different. Some want this, some don't want this. So we need to also consider those differences and designs overall. For example, maybe for smoothing music, people don't want it and not hate it. So this is a good choice. But for bird sound, although many people like it, 20%, but 45 or 50% don't like it. So maybe we should not use it. So with these two figures, we can have some kind of design guidance for different sound, different activity. So now let's move to another type. I just want to show you different types we need to consider sound. Shopping mall. This is Sheffield, UK, Meadowhall, which used to be the largest shopping center in Europe when it was built in 90s. Very big. It's converted by a old industrial building to a shopping center. So this is a typical sound level in a kind of a shopping center. Now in China and everywhere in Asia, there are many kind of this kind of big shopping center. You can see the sound level is quite high. It's about 70 dB and could be 80 dB. And the spectrum is like a middle frequency dominant, which is dominated by speech. Uh, Speech's typical spectrum is like that. High, middle frequency dominant, not much low frequency, not much high frequencies. So generally speaking, with increase of sound level, people's acoustic comfort do become less. So that's expected because, as I mentioned, now the level is over 68 dB. At this kind of level, we do need to think about reduce noise level, maybe by adding more absorption and also have noise barriers or design zones differently. But uh, interesting thing is, although we found this kind of generally people not satisfied, no difference between, not much difference between different age group, um, and also we didn't find much influence of people's home environment. So these are kind of general finding. Most interesting finding was when people firstly arriving in the shopping mall, they do feel acoustically uncomfortable because suddenly they come from maybe quiet area, suddenly come into space feels so reverberant and noisy. But after a short period, they might get used to it. So it means the people's evaluation is not kind of fixed, like shopping mall, how is your evaluation, depending on when is it. First arrive, you feel it's uncomfortable, but then you feel it's okay, you get used to it. But that's most interesting phenomenon. After a longer period, they might feel uncomfortable again, and then as they become tired with noisiness and annoyance. Now this is more health related. Maybe they feel physically uncomfortable after this long uh, exposure on noise. So what does it mean for design? It means, of course, we need to reduce noise level and reduce reverberation time, make people feel comfortable when they first arrive. But more importantly, we should have a place for people to have rest after certain period. So we found about half an hour, 40 minutes, this period, people become uncomfortable again. So for about half an hour, 40 minutes, shopping distance, not walking distance, but shopping distance, we should design a place for people to rest and quiet zones so people can recharge, become comfortable again, and continue shopping. So this is kind of power of considering people's perception to guide design. So now let's move to library reading rooms. Um, so I think everyone in university know library reading room. And firstly, we measured the sound level, relative sound level. See, if you have a sound source, we play some sound at one end of reading room and measure sound level. See how much it will attenuate. The more, the better, of course. That means if someone is making noise here and other people can't hear much, which is the case in this reading room, because you can see along the length, there are about more than 10 or 15 dB noise reduction. And also reverberation time is very short because there are many books. Normally, we know that when reverberation time is very long, like church, people don't feel comfortable and feel disturbed. But now it's very short. So given this acoustic design, if you only think about physical aspects, this library reading room should be fine because it's got quite good sound attenuation, very low RT. But actually, when we did the survey, we found the acoustic comfort is only at the medium or less satisfactory level. And there's no correlation between sound level and acoustic comfort evaluation because we measure different time at different sound levels. So that's um, kind of quite strange because if you only think about the physical aspect, it should be fine, but actually perception-wise, it's not. So this also indicates we need to consider people's perception more, human-centered design more. So after some detailed examination, we found the reason people didn't like it was some people think the place is too quiet. Some people think it's too noisy or quiet, and some people think it's too noisy. This is very interesting. Why people have such different perception. Then we found actually people who feel the place is noisy, too noisy, is because it's too quiet. When it's too quiet, then any noise will make people very annoyed. That's why the average comfort level is not high because some people think it's too noisy. So what we did was we put 4 loudspeakers in 4 corners of this library reading room and play some sound from recorded from raining and wind, raining sound and water stream, and also ventilation sound. We measured from ventilation opening and played through loudspeaker. And we increased the sound level to 50 dB. And so we asked the student again, what do you think? And at the end, we found actually in terms of different aspects, the sound acoustic comfort are improved, although we increased the sound level to 50 dB, which is not very high, but higher than the previous background. And also we found the running water sound gives the best performance, maybe because it's weak low frequency component, smaller dynamic range, or because it's natural sound. And we found also ventilation sound give worst performance because maybe that's artificial sound. As I said, I wouldn't go to too much detail on each building type because we got papers you can refer to, but I just go to different building type to show you, demonstrate the importance of the human-centered design. And the football stadium, what is requirement there? We surveyed a range of kind of medium-sized football stadium and again, ask people what kind of environment you want. And we found the measured average sound level is about 77 to 80, 98 dB. Maximum is 100 to 120 dBA. This is peak. So for people who knows decibel scale, you will know that's very, very high. For example, in factory, if the noise level is higher than 85 dB, you're not allowed to work for 8 hours. If it's 90, you are not allowed to work for 4 hours. The working hours must be halved. So this is very high. And the survey shows the response to 2 questions regarding the quality of atmosphere and the loudness were very similar. most fans do think that atmosphere is very, if not totally, depending on sound volume. So the louder, the better. So, the answer for these two questions are very similar. Uh, do you prefer loudness to be high? Yes. Do you like that atmosphere? Yes. And um, an audible PA system do not seem to contribute to good atmosphere because for this kind of places, audible PA system is very important. If there's fire, people need to run safely, um, evacuate safely. But for fans, if there's no fire, they don't really care. So of course, as a designer, we need to make sure that they can hear it. But during the match, there is no emergency. They really think the loudness is very important. And fans want to hear sound from pitch better than they could, so they demand more. And external noises such as wind, rain, and traffic, uh, uh, they could hear externals better than they like to. That means they don't want to hear other sound, just fans sound. So the challenge here is not about how to design good PA system and also how to reduce noise, but it's how to amplify the fan sound and not other sound. So uh, with this kind of target, I'm sure we can think about a certain kind of design strategy. Swimming spaces is another kind of common space people go. And this is sound level we measured. You can see it's not that high normally, but there could be some, for example, this one, Hillsborough one, is quite high, almost 80 dB. Not much as football stadium, but still quite high. And it's continuously high. And we found the correlation between reverberation time and acoustic comfort is like people prefer long reverberation time, although the reverberation time is already quite high in swimming spaces, as you can all imagine. But people still feel longer one, they feel atmosphere is good. And they don't like high sound level. You can see with high sound level, their satisfaction is low. And uh, in terms of liveness and reopening time, is no clear or strong tendency or preference. So that means in swim spaces, it's okay to keep long reverberation time, but to reduce uh, sound level. And 50% of people think acoustic is very important issue in swim spaces. And 75% of people think the major noise source is children's shouting. So we need to think about how to maybe divide this into two zones for those who have children and don't have children, or other kind of treatment like management maybe. And 32% of people feel acoustically uncomfortable after swimming, and another 33% sometimes have this feeling. So that's more physical, uh, physiological side. So we need to think about how to really ensure people's health is not affected when they go to a place to enhance their health. Um, Another final type is church. So in church, there are two functions. One is people go to church to enjoy, to feel the atmosphere, to interact with others. Another function is people want to go there to listen what the priest is saying. So, and uh, we found this is reverberation time we measured in different churches. And people do feel with increase of reverberation time, their kind of preference and increase atmosphere is good, but the speech intelligibility is worse. So those two are contradictory. So we need to think about how to balance the function and also the atmosphere. And the survey generally shows uh, people prefer atmosphere rather than speech intelligibility. If they must choose between those two, they prefer good atmosphere rather than just the clear speech intelligibility. So that's the difference between going to church or concert hall. If you go to concert hall, I'm sure the results shows the preference is different. Actually, this is a good example about um, function and atmosphere for non-acoustical spaces, what we should choose. So I hope with this discussion of different building types, it's very clear we need to consider people's perception, human-centered design, and there are a lot of information we should consider to guide us to design. Now, finally, it's about how to design it. For example, what we can design as a designer. So we derive this framework. For example, for open public spaces, we can say we can design every source, space, people. We can't design people, but we can design according to people's need or for people, and also other environments. For example, audio-visual interaction, thermal, sound interaction. So you can see in our hand, we have many parameters to design to achieve human-centered design. I wouldn't go to too much detail, but you can see from each source, we can design sound level, spectrum, how it changes with time, where it's located, whether it's moving or not, what's the feature. For example, is that a sound mark, like Big Bang is sound mark for London. And also we can design reverberation time, reflection pattern, and also whether it's quiet space in noisy environment or noisy or a lively space in quiet environment. And for people, as I said, a lot of information about demographical and social aspect. And also we have this interaction between temperature, sound, visual sound, and the smell sound interaction. So these are the designable factors, but how do we design them? So if there are audience from architectural background, we know that architecture design is more traditionally, at least, subjective one. I like it, therefore design like this, and I assume my user will like it. But technical design is, okay, I have target 50 dB to achieve. If I achieve it, I'll assume people like it. But for soundscape design, human-centered design, we need to really think about for different stages, setup, preparation, design, evaluation, and the future development, what do we want to achieve? Not only decibel level, but also people's comfort. And who should we involve? Different users and management, and how do we involve them? And what do we want to achieve? So that's kind of overall design framework for human-centered design for building and the environment. And of course, we don't have to tick all the boxes, but this is kind of completed picture we could follow so that we can achieve something better than traditional architecture design because we have a technical component in, and also better than traditional technical design because we got a human-centered component in. So with that, I'll conclude. Acoustics is very important in many non-acoustic spaces, not only the one I showed you, but also many other non-acoustic spaces, restaurants and other places, atrium spaces. And the outdoor and indoor soundscaping, including atmosphere and acoustic comfort, may vary considerably with the same objective acoustic indices. Same decibel level, same RT, the acoustic atmosphere could be very different. Therefore, we really need to consider people, human-centered. And the current guidance and technical regulation are insufficient in terms of acoustic design of those spaces. And the relations based on the survey, as I showed, something like that, between subjective and objective indices would be very useful for developing future design guidance for building and the environment. So finally, I'd like to thank the invitation by the organizer, by the journal and the chief editor to invite me to give this talk, and also like to acknowledge the research team members and the collaborators over the years for this set of work, and also, of course, founding bodies. And if you would like to have more information, because I went through quite quickly for different building type, you can go to my Google Scholar site to have more information on detailed papers. So thank you very much for your attention.
Thank you. Thank you so much, Prof. Khan. Thanks for your wonderful talk about the acoustic perception of wires outdoor and indoor spaces, including the open public space, hospital, care facility, library, and also the church. Thank you so much. So anyone have some questions? So Prof. Khan, can you see the comments at right side?
Ah, there's a question. It says, could you speak Chinese to answer the question? Okay. The question is from the many questions. What is most difficult question? How to solve the question? What is question you can never solve? What's the reason? And I think this is very big question. Uh, so I'll answer in Chinese, maybe. 我想最难解决的问题就是众口难调。怎么解决呢？就是比如说在一个地方，把它分成各个区，这样的话，个人有自己的选择。另外呢，随着现在这个新技术的发展，比如说现在有这个强指向性的声源，还有那个 AI，可以识别人哈，不一定是人脸，就是的类型，这些呢都可以解决这个众口难调的问题。呃，你说产生问题的根源是什么呢？根源就是每个人不一样，他不一样，无论是生理、心理，可能都会有不一样，所以呢，就是这是产生这个问题的根源。第二个是what is 呃 what is sound can never exist or uh, can never design. I'm not very clear about the question. So，我想问题就是说，我们首先要考虑人的健康。假如是比较长期的，比如说100分贝以上的话，这样的声音是，即使人们感知到它是好的，也应该考虑人的健康。比如说，一个十几岁的孩子，他去 disco，110分贝的声音很让他愉悦，但你不能老让他去 disco，所以这要考虑人的健康，像这是一个非常重要的方面哈。就是这个 human-centered 一定是考虑他的感知和健康是那个呃，就就是要平衡哈，不能喜欢什么就一直给你吃，你喜欢甜食我一直给你吃甜食，那这个人就废了哈。
For time issues, Prof. Khan, you can pick one or two questions to answer. Okay. Yeah. Thank
Yeah,
you.
yeah, I think those questions are related, so that's yeah,
Yes. Yes.
answer yeah. Do you think that the problem is that lack of regulation or lack of awareness of the topic at more wide? Yeah, I think the question is the current problem because of lack of awareness or lack of regulation or what? I think it's both. The example I showed you about urban public spaces, that research is pushed by the EU directive, which is a very strong regulation. If any city doesn't do quiet area protection, then the country will fine this city. And if any country doesn't do it, the EU will fine the country. So that push a lot of research. But on the other hand, regulation comes from people's awareness and also complaints. So it's kind of egg chicken thing. People need to aware it and shout about it. Then there'll be regulation. Then it will push practice, regulate, kind of design guidance. So, and also with increase of uh, quality of life and people's awareness demanding, this will come very soon. This was the situation in Europe and is the situation in China, also many Asia countries, I think. Yeah, the time for considering acoustics better or more carefully is coming.
Thank you, Prof. Khan. So do you have any other questions? Popcorn, I want to use this opportunity to ask a question. So,
Yeah.
AI is growing very fast, and we know AI can be used to generate some images, text, or videos, music, and also some songs. So, can you recommend or give us some suggestion? What are the challenges and also the advantages that for the AI applications and AI technology can be used for the architectural, acoustic, and also the human-centered comfort design? Can you give us some suggestions?
Yeah, very good question. Very important question. Actually, we have a small research team working on this about generating AI-based sound environment for design. The main challenge is you can generate any sound, but how do you know the sound is good? Also, we are generating sound environment for building an environment. It's not a single sound. If you say I generate a sound for printer, that's much simpler. High frequency, low frequency, you can do whatever. But the combination is so complicated, so many possibilities. So now the key question is, you can generate anything, but how do you make sure this is good? Good not only for one person, but for all people. Therefore, the key is to have a big database to know the demanding, which is what I showed you, so many surveys. And this is the key for AI generation of sound environments and how to integrate that into the generation system. Yeah.
Yeah, thank you. Thank you so much for your good suggestions. So for time issues, so we will stop here. We will conclude this forum, and we hope that in the future we can also invite you or your colleagues to give us some wonderful talk. Thank you.
Okay, great. Thank you, Professor Zhang. No, thanks for journal, and thank you everyone for your attention.
Okay, thank
Bye,
you.
everyone.
Bye.
Bye, bye.